So this was a weekly pop quiz which was related to the periodic table. We'll start with the discussion of this pop quiz. So in the first question, we have different halogens. We have fluorine, chlorine, bromine, which are group 7 of the in the group 7 of the periodic table. State the name given to group 7 elements. So group 7 elements, what we say, we call them halogens. The term halogen means salt former. They form salt, that's why we call them as halogens. Explain why group 7 elements have the similar chemical properties. The chemical properties depends on number of electrons in the last shell because they all have same number of electrons in the last shell. And what is that number? That is 7. So they all have 7 electron in the last shell. That's why they are having the same chemical properties. Then we have to write the appearance of these and the states. Fluorine is light yellow or pale yellow. Chlorine is yellowish green. And bromine is red brown. If you just write red, that's not correct. If you only write brown, that's also not correct. You should write complete red brown. Okay. Then what are the states? Fluorine is a gas. The first two members are gas. Then bromine is a liquid. Then iodine and astatine are solid. In part D, bromine has two naturally occurring isotopes. One is 79, another one is 81. State the term given to a number 79 and 81 in these isotopes. So what we call this, we call that as nucleon number. Nucleon number means it's the number of the proton and neutron. Then we have to complete this table. So to complete this table, you have to use a periodic table. So using a periodic table, you will find the proton number of a bromine because proton, but don't write the nucleon number from there because you may have a different isotope given in the question. So you will just use the proton number. So when you check the proton number for bromine, that is 35, the number of the proton. So because proton number is the identity of the element, so this should be 35. This should also be 35. For electrons, it's a neutral. For the first isotope is a neutral, that is 35, but the second one is an ion. It has a charge of -1, so this should be 36. And to get the number of neutron, the nucleon number minus the proton number. So 79 minus 35. So it will be 44. And this one will be 81 minus 35. So 46. So this will be 46. So this is how we complete. Okay. So for only check the proton number, don't use a nucleon number from the periodic table because in the question you may have an isotope. If an isotope is given, then it won't be correct. Then table 2.3 shows the relative abundance of two naturally occurring isotopes of bromine. Table 2.3, we have one bromine 79 is 55% and bromine 81 is 45%. How to work out an average mass of the two isotopes from their relative abundance? So percentage of the first isotope multiplied by mass of the first isotope plus the percentage of the second isotope multiplied by mass of the second isotope and divided by the total sum of the percentage, which will be 100. Sometimes they give the fraction, so you will use a fraction here. Like maybe they give the fraction as, say, example, 2:1. So how you will solve if the fraction was given, then 2 times 79 plus 1 times 81 and divided by 3. the sum of the fraction. But if the percentages are given, then the percentage of the first isotope multiplied by mass plus the percentage of the second isotope multiplied by mass divided by 100. And write your answer in three significant figure whenever you get this answer or one decimal place. So it will be 79.9. So 79.9 will be the relative atomic mass. And you can say the unit, if you want to write a unit, it will be gram per mole, like mass of 1 mole. But the unit is not having a mark here. 1 mark is for doing this calculation. 1 mark is for the right answer with the correct number of significant figure and the decimal places. So if you want to work out an average mass of the isotope, it's percentage multiplied by mass plus percentage multiplied by mass into divided by 100. In part E, chlorine displaces bromine because we know more reactive halogen displaces the less reactive halogen from an aqueous potassium bromide, but does not displace fluorine from aqueous sodium fluoride. Write a symbol equation for each reaction between chlorine and aqueous potassium bromide. For a reaction between chlorine and aqueous potassium bromide. So chlorine is there. So chlorine, because it's a non-metal, the symbol is Cl, but it's a non-metal, so it should be Cl2. Reacted with potassium bromide. So how to write whenever you're writing a formula of a compound, use the valencies, use a periodic table. Potassium belongs to group 1 plus 1 and bromine is group 7 minus 1. So potassium bromide will be KBr. First, whenever you're writing an equation, don't try to balance the equation. First, try to write a correct formulas for reactant and a product. Then later try to balance. Don't try to balance from the beginning. Then what will happen, because chlorine is more reactive, so chlorine will displace bromine. As a result, what it will form? It will form potassium chloride. What will the formula for potassium chloride? Potassium is plus 1 and chlorine is minus 1. So potassium chloride will be KCl plus bromine is removed. But again, bromine is a non-metal. So non-metal should exist as a molecule except group 8 and group 4. Group 4, like example, if you were having carbon, silicon, we don't write as C2, C6. We don't write, we write only C because they have a tendency to form a long chain compound, catenation. Now, second part is a balancing. We have 2 chlorine, so we put 2, chlorine is balanced. We have 2 bromine, we put 2, bromine is also balanced. And this equation is balanced in terms of all the reagent, even potassium as well. Then state why chlorine does not displace fluorine from aqueous sodium fluoride. The reason is that because chlorine is less reactive than fluorine. Then aqueous silver nitrate is a colorless solution which contains silver ion. Describe what is seen when aqueous silver nitrate is added to sodium chloride. So we have silver nitrate AgNO3 and we add it to sodium chloride NaCl. As a result, it will form AgCl silver chloride plus NaNO3. All nitrates are soluble, so this will be aqueous. Most chlorides are soluble except silver, mercury, and lead, so this will be aqueous. But silver chloride is insoluble, so solid, and this will be aqueous. So what is the appearance of silver chloride? You have to learn, like if it's a silver chloride, it will be white. If silver bromide, it will be cream. And if it's silver iodide, it will be yellow. Like silver, you have to learn the colors of silver halide. Remember, if you have AgCl, remember the color should be white. If you have AgBr, the color should be cream. And if you have AgI, the color will be yellow. Same thing you can remember for lead as well. Like if you have lead chloride, PbCl2, if you have lead bromide, PbBr2, and if you have lead iodide, PbI2, so color of the precipitate will be, so try to memorize these colors. So appearance, it will form what is seen. So we'll observe white PPT. Precipitate means when you mix the two solutions and a solid is formed, we call that as precipitate or PPT. Write an ionic equation for aqueous silver nitrate. So the simple way to write an ionic equation, just write solid, liquid, and a gas. So what is, there's no liquid or a gas, only solid is there. That is AgCl. So what are the ions present? The silver plus one ion is there. That's already given to us. And ions are aqueous, and the chloride ion is there. That is aqueous. So silver ion and chloride ion react to form silver chloride, AgCl. This is a very important part in periodic table chapter. You will find every time similar questions are there. In the question 2 is the multiple choice question. Q and R are elements in the same period. So when we say elements in the same period, means they will have the same number of shells. Okay. If we say elements in the same group, then they will have same number of outer shell electrons. Q has 7 electron in the outer shell. So Q is having 7. So if it 7 electron, what this information, like how, what information we get having a 7 electron? So this give an idea that is, it is a non-metal, because having 4, 5, 6, 7 or 8 electrons in the outer shell means a non-metal. R has 2 electron in the outer shell. So what this give an idea? This give an idea that R is a metal, because 1, 2, and 3 it will be a metal. Which statement about Q and R is correct? Q is a metal and R is a non-metal. That's opposite. Q and R have different numbers of electron shell. That's again wrong, because as they belongs to the same period, they should have the same number of shells. R is found to the right of Q. Where we find R, because R is a metal, metals are in the periodic table. If you see the metals, like this is a periodic table, where you find the metals, if we draw the stairs, so left of the periodic table we'll find metals, and right of the periodic table we'll find non-metals. And we work out R is a metal and Q is a non-metal. So R is on the left of Q, not right of Q. So R is found on the right of Q. No, it's not on the right, it's on the left. Then the last statement, the proton number of R is less than the proton number of Q. That's obvious, because R is having, because they're in the same group, and as we move across the period, the proton number increases. Like there will get more protons. That's why D is the right statement. In question 3, which statement about alkali metal is correct? What is the periodic trend for alkali metals or a group 1? The melting point decreases as we go down the group. The density increases as we go down the group. The reactivity increases as we go down the group. Okay. So the elements which we have lithium, sodium, potassium, rubidium, cesium, francium. These are the elements. Lithium is more dense than sodium, but as we go down the group, the density increases. So it should be opposite. Sodium should be more dense. Sodium is more reactive than potassium, but as we go down the group, the reactivity increases. So potassium should be more reactive than sodium. Sodium has a higher melting point than potassium. The melting point decrease. So sodium melting point will be higher than potassium, because like as we go down the group for alkali metal, the melting point is decreasing. Down the group, they have low melting point, top of the group, high melting point. So sodium is above potassium. So yeah, that's right. And they are in group 2 of the periodic table. This statement is totally wrong, because they are in group 1 of the periodic table. In question 4, which row describes the properties of the transition elements? Melting point should be high. Density should be high. Form colored compound? Yes. Or the elements or their compounds are catalysts also. So high, and yes. So which one it match with? It match with option B. So this was a pop quiz, the first pop quiz of the week, which was related to periodic table. The second pop quiz was related to metals that we'll discuss in the next session. And now we'll start with the metal topic. We'll try to complete because I give you one homework about the MCQs. So I want to complete this metal topic today.